Hi, welcome to my channel. Today we are diving into Google Cloud's VPC Network Peering, a critical component for designing secure and efficient network architectures in GCP. Whether you're optimizing your cloud network or exploring new ways to connect VPCs, this video will provide you with an in-depth insights and best practices. So let's get started. In Google Cloud Platform, VPC Network Peering enables seamless communication between different VPC networks within your organization. By connecting VPCs using internal IP addresses, VPC Network Peering facilitates secure, low latency communication while avoiding the complexities and costs associated with external IPs. This approach adheres to the principle of separation of duties, ensuring that each VPC can have distinct administrative controls, such as routing management, firewall policies, and VPC configurations, while still allowing necessary inter-VPC communication. Now let's discuss the key benefits of using VPC network peering. First, it offers enhanced network security. VPC network peering ensures that resources communicate over internal IPs, significantly reducing the attack surface and minimizing exposure to external threats. This setup is designed to keep your network communications private and secure. Secondly, it offers reduced network latency. By keeping traffic within AWS's high-performance global backbone, VPC network peering minimizes latency and ensures faster communications between VPCs compared to using public internet routes. Thirdly, it offers optimized network costs. Avoiding external IPs mean you don't incur additional egress charges. Instead, you only pay for standard network usage, making your network operations more cost-effective. VPC network peering supports the exchange of various type of routes. First, it supports subnet routes. Subnet routes are exchanged automatically if there are no privately used public IP addresses. For VPCs with such IP ranges, explicit route export is required. Secondly, it supports custom routes. Custom routes, including static routes or those learned via BGP, needs to be manually configured for exchange. This ensures that specific routing needs are met across peered VPCs. There are important considerations to keep in mind. Ensure that IP address ranges within peered VPCs are unique to avoid routing conflicts. Effective IP planning and subnetting are crucial for maintaining smooth connectivity. Second consideration to keep in mind is of non-transitive nature of peering. VPC network peering does not support transitive routing. For instance, if VPC-A and VPC-B are paired, and VPC-B and VPC-C are paired, VPC-A cannot communicate directly with VPC-C. Direct pairings are necessary for inter-VPC communication. So to maximize the benefit of VPC network peering, you have to follow the following best practices. First, plan your IP addressing scheme carefully. Use a hierarchical IP addressing strategy to prevent overlaps and conflicts, aligning with your organizational structure and network segmentation needs. Secondly, implement least privilege access. Use IAM policies to enforce least privilege principles, restricting VPC network peering modifications to authorized administrators and sharing only necessary routes. The third best practice is to monitor network traffic and logs. You may utilize Google Cloud's monitoring and logging tools to track traffic patterns and detect anomalies. Set up alerts for potential security issues or configuration changes. The fourth best practice is to regularly review peering configurations. Periodically assess your VPC peering configurations to ensure they align with current organizational needs and security policies. Remove any unused peerings to streamline your network and reduce potential vulnerabilities. I hope you found this walkthrough of Google Cloud VPC Network Peering insightful. If you have any questions or want to share your experience with VPC peering, drop a comment below. Don't forget to like, subscribe, and hit the notification bell to stay updated with more in-depth cloud architecture content. Thanks for watching and see you in the next video.